In this video, I will demonstrate how to analyze data for two independent means from beginning to end. We'll be using this example. Researchers gave 40 index cards to a waitress at an Italian restaurant in New Jersey. Before delivering the bill to each customer, the waitress randomly selected a card and wrote on the bill the same message that was printed on the index card. 20 of the cards had the message, "The weather is supposed to be really good tomorrow. I hope you enjoy the day." Another 20 cards contained the message, "The weather is supposed to not be so good tomorrow. I hope you enjoy the day anyway." After the customers left, the waitress recorded the amount of the tip as a percent of the bill before taxes. Is there evidence that the two different messages produced different tips? So this is a case where we have two independent groups that we're comparing. We have the group that received the good weather message, and we have the group that received the bad weather message. And it wasn't the same customers. I mean, there were different customers in both of the groups, so the two groups were independent from each other. Knowing who received the good weather message does not tell you anything about who received the bad weather message. So independent. So first thing we're going to do is write our hypotheses. Our null hypothesis is going to be that the mean tip for the good weather message is equal to the mean tip for the bad weather message. And our alternative hypothesis is going to be that the mean for the good weather message is different from the mean for the bad weather message. And where did that different from, not equals to symbol come from? Well, we look at the keyword given in the original question, which wanted to know if the different messages produced different tips. So different is our key word for not equals to. The type of test that we're going to be doing is two means for independent samples. So first thing we need to do, and this would kind of go along with the collect the data step, is just get all the data inside of Excel ready to analyze for us. So we're going to be using the quantitative inference procedures Excel spreadsheet, and we are doing the two sample t-test. So in Excel, click on the two sample t-test tab, and then you're going to enter the data in the two columns that are off to the left. So I have one column for all the good weather news tip percentages and one column for all the bad weather news tip percentages. Once we've got the data entered in, we're ready to move on to the next step, which is to describe the data. And we're going to want to describe the data both graphically and numerically. Starting with graphically. One graph that's good for comparing two independent samples is to do side-by-side box plots. So in Excel 2016, it's only in version 2016, and it also only works on a PC. If you have the Mac version, it doesn't have this capability. But if you have Excel 2016, then first thing you need to do is highlight the data in Excel. Once you have the data highlighted, you're going to go to the Insert menu and you're going to choose Recommended Charts. Then you're going to click on the tab that says All Charts, and down here, almost near the bottom, there's an option for a box and whisker plot. So I'm going to click on that box and whisker plot and click on OK, and that's actually going to pop this nice box plot, side-by-side box plots, right here into my Excel worksheet. So looking at my graph here, you can see that the blue box for the good tips is higher than the red box for the bad weather news tips. I love box plots because I think they're very visual in terms of comparisons. It's very clear to see here that you do get better tips when you give a good weather message rather than a bad weather message. To do histograms in Excel, we're going to have to use the quantitative descriptive statistics Excel spreadsheet, that's a mouthful, that we used a lot at the beginning of the semester. So here I am, I'm in the original quantitative inference procedures spreadsheet, but I'm going to copy the data, and I can just only do one group at a time. So I'm going to copy the good data first from this Excel spreadsheet, and then I am going to change over to the quantitative descriptive statistics spreadsheet, where I'm going to paste the good data in there. So once I paste the good data in there, then you can see that it creates a lovely histogram for me. And I could mess around with the number of bins if I wanted to. just to see what I think. Or if you think 5, the default looks good, you can keep it at that. I'm going to do this for both sets of data, so I have to do them separately, and I can just copy and paste those histograms so that I have both of them to examine together. Here's our histograms kind of on top of each other. Looking at them on top of each other this way, we can also compare the two groups. So you can see that the good group on the top had higher overall tip percentages than the bad weather news group on the bottom. Now that we've compared the data graphically, we're ready to compare the data numerically. We're going to do this just by comparing the means and standard deviations. And that quantitative inference procedures spreadsheet makes this super easy for us. You can see that once we've entered in the data, so I haven't done anything since just entering the data, then we get this nice box here that includes means and standard deviations for both groups. And looking at these, you can see that the mean for the good weather group was 22.22 and the mean for the bad weather group was 18.19. So we can see that for our sample means, definitely the good group looks like it was better than the bad group. All right, once we've described the data, we're ready to check the conditions to see if we're ready to go ahead and analyze the data. For a 2-sample independent mean test, there's 2 conditions. First, both samples must be independent random samples, and second, that both populations are normally distributed or both sample sizes are at least 30. So for our first condition here, it said that the waitress randomly decided which customers were going to get which message. So we do have a random sample, and as described earlier, those 2 samples are independent because knowing who is in the good weather group doesn't tell you anything about who's in the bad weather group. So we meet condition number 1. For our second condition, we need to have both populations be normally distributed or both sample sizes are at least 30. Now our sample size was n equals 20 for both groups, so we do not meet the second part of this, but if the populations are normally distributed, then we're okay to go ahead and conduct the analysis. We can check to see if the populations are normally distributed by doing QQ plots of our individual samples. If the QQ plots show that the data is close to normal, then we can assume that the populations are close to normal as well. To do a QQ plot in Excel, I'm first going to copy the data from the spreadsheet that I did the histogram on, and then I'm going to go to the QQ plot tab down here and I'm going to paste the data in here. So I paste that data, and once you've pasted the data, and this is very important, you have to sort the data. So if I click on the data tab up at the top, and then I'm going to click on sort, and the way I pasted my data, I pasted it with the name there as my header row. So I'm going to make sure that the box that says my data has headers is checked. I want to sort it from smallest to largest, so I click on OK, and now you can see that I have a QQ plot that I can look at to determine whether or not my data was normally distributed. So here's what both QQ plots looked like after I did them both, and you can see that the points roughly fall on the straight line there. There's not a lot of curvature. They're not perfect, but they're pretty close to the straight line. So they're good enough that we can say, okay, I think that our populations are normally distributed, and we meet the second condition, and we can go ahead and do the analysis. So remember, we're testing null hypothesis. The mean for the good weather message is equal to the mean for the bad weather message, and the alternative hypothesis is that the mean for the good weather message is different from or not equal to the mean for the bad weather message. And we're going to be doing that 2-sample independent test inside of Excel. So really important is that we need to enter in the type of test. And this type of test comes from our alternative hypothesis. So ours alternative said not equal to, so we'd enter in not equal to here. This is a place where a lot of students forget, and then it's going to give you not the right answer in the end. So make sure you enter in the type of test, the type of alternative that you have. Once you've entered that in, Then down below, you're going to get all the other information you need. So you can see that we have a test statistic of t equals 6.274, degrees of freedom equal to 37.795, and p-value here, really small, essentially 0. So this little e here indicates that we're using scientific notation, so it's really 2.67 times 10 to the negative 7th, which would be lots of zeros after that decimal place, and essentially meaning that our p-value is 0, or really close to 0. So if our p-value is close to 0, we know that when p is low, HO must go. So we would reject the null hypothesis and conclude that the alternative is true, that we have sufficient evidence that the messages produce different tips, or that the mean for the good weather message is different from the mean for the bad weather message. So now what you must be wondering is, how much more were the tips? Like, is it worth it to go to the extra effort to write this good weather message? Well, we can tell based on our means that the good weather message produced higher tips than the bad weather message. And we can construct a confidence interval for the difference to estimate what that difference would be for the population of all tips. So we're going to do a 95% confidence interval. So back in Excel, again, this is very important and something that a lot of people forget, is that you need to enter in the level of confidence that you want to have. So the default is 95, but oftentimes questions on quizzes or tests might ask you for a 90 or a 99% confidence interval. So you want to make sure that it's set correctly here. Once you do that, then the confidence interval magically appears right at the bottom. So looking at our confidence interval, we can conclude that we are 95% confident that the difference in the mean tips for the good weather message versus the bad weather message is between 2.729% and 5.331%. In other words, if you write a good weather message on the bill, you're going to get somewhere between 2.7 and 5.3% higher tip percentage than if you wrote a bad weather message. So last part of our analysis, take action. So more tips is more tips. If you work as a server in a restaurant, don't write any depressing messages on the customer bills, and consider writing a positive message on the bill to hopefully increase your chances of getting a higher percentage tip and taking more home to the bank at night.